Hello everyone, my name is Ahmed and I hope you are doing well. Welcome in my YouTube channel. So our today's problem is it is one of the most important interview question. Write code to reverse the list in place without using built-in reverse method or slicing. Uh, Actually, both of the methods are very easy and both built-in reverse method and slicing method is one line problem. I will show you how to do them as well. So this is our input list, 37248, whose length is 8, and the output, expected output is the reverse of it. Like uh, in this list, actual list, 5 is in the last. So in the expected output, 5 is in the start, and 3 was the first element. And now 3 is the last element. So that's how our output would be look like. I know this is not a difficult problem. It is an easy level problem. And I will also show you how you can reverse the string. This is the numbers and you can also reverse your string. But before moving into the question directly, I want to review these concepts. These are very important concepts. And whenever you start DSA, you will, of course, encounter these problems in your life. So let's see one of the most important term uh, in the problem solving world, algorithm. I know you must heard this before. So let's see. An algorithm is a step-by-step instructions designed to solve a specific problem or complete a task. Basically, you can understand as there is a machine and you give input to that machine and that machine perform some calculation and apply the logics that you give to that machine, and in the last it give you the output. So this is the algorithm. The logic that machine is using is basically the algorithm. And last line, it takes an input, process it through a logic steps and produce an output, as I told you. For example, here is an example. You want to make a tea. What you will do, you will boil water, you will add tea leaves, you will add sugar, milk, whatever. And in the end, if you feel like after boiling 5 to 6 minutes or 10 minutes, you see, oh, the it is getting ready, and lastly you will pour it into the cup and start having it. So this is basically the algorithm. Or if I give you another example, for example, if you want to make a cake. So as you know that everyone has a unique recipe to make the cake. If you will make the cake, your texture, your design, color of the cake will be different than me. So the algorithm you are applying will be the step-by-step logic you are using. So this is exactly the algorithm. See some real life example when you uh, this is a GPS navigation example, but you must use Google Map in your life. So that also use algorithm because it tells you the fastest route by analyzing the real-time traffic data, and also tell if there is a road closure. Of course, if it has all data, so how it can tell you if there is a road closure, or for example, if there is a new street government has created. If map does not have a new data, so it will be fair to tell you the shortest path or the best path. Next is a facial recognition. Whenever you try to open the phone, this technology mostly used in new phones. So your camera asks, your facial expression, try to matches your facial expression with the facial expression that is available in the database. If both of them gets matched, so it will unlock the phone. Otherwise, it will show the error. Your facial expression is not matched. Someone is trying to open your phone, etc., etc. So next, one of the most important term is data structure. As its name suggests, data should be in a structural form. For example, if you see a contact list in your phone. If it is not in a list, so how it will be very difficult for you to search any number. For example, you want to find John. So John starts from J. So you can directly go to the section of J and dial your desired number. But if your desired number is not in a list or not in a structured manner, so it will be very difficult for you. So you will start at the beginning and go up to so on the last. If you are lucky, so you might find your desired number in the start. Otherwise, you can find in the middle or maybe in the last if you are very unlucky. So for this method, we need data structure. Data structure is basically a way to organize and store data efficiently. So here are some examples of data structure arrays. Arrays basically is a type of data structure which store data one after another. In a memory, it's stored like if one element is stored at 1,000 location and one element contains 4 bytes. So next element will be at 1,004th location. Next element will be 1,008th location, and third element would be 1,012th location and up to so on. So this is array. Next is stack. As its name suggests, elements are available on top of each other. If you see, we give you the real life example of stack. So you must see in the stack of plates, you see a stack of books, etc. So this is also very important algorithm. Next is queue. If you go into the crowd area or if you go to watch movie and you don't book your ticket in advance. So you would go on a counter. So you must seen a queue, long queue. So people are waiting on their turns, and when they free, then your turn comes, etc. This is also the crucial algorithm. Next is uh, dictionary. Dictionary is basically different from all the above data structure that we have seen, stack, arrays, and queues. This is a combination of keys and value. If you have seen a real life dictionary, so you must seen there is a word and respectively there is its meaning. So understood? Key is the word and its meaning is the value. So next is time complexity. Very, very important. I'm telling you, if you want to become master in DSA, so you would be learn this thing, time complexity. Time complexity describes how the runtime of algorithm changes as input size grows. Okay, if you have a small input, so you will see how much time your algorithm is taking. If your data is too much big, like if you want to add 1,000 or 1 million or even 1 billion numbers, so how you will see how your algorithm is working. Okay, so that's exactly is the time complexity. It does not measure actual time in seconds or milliseconds because that depends on hardware and system performance. Instead, it measures the number of basic operations like comparison, addition, loops, and algorithm perform. So why the time complexity really matters? So we as a human always want efficient solution in everything. You want if you want to buy a house or so you will try to buy in a minimum price and that would be in a very good situation. Still same example with the car. So in a low price but that gives you the high mileage or etc. etc. So a problem can often be solved in different ways. Time complexity help us compare solutions and choose the one that works efficiently for a large amount of data without slowing down the system. So we need efficient solution as I told you. So here comes one of the important term when we discuss time complexity is big O notation. Big O notation. Big O or notation represent the worst case performance of algorithm. How much worse the algorithm can be performed. As I give you the example of contact search in your mobile. If it is not in order, so it will be take a lot of time. But if it is in order, you would probably find the desired number very efficiently and very quickly.
Yeah.
So the common types of big annotations. First is order of one, which is constant time. Order of one doesn't mean only one element will be performed or it will take 1 second. It doesn't mean. So basically, it's mean execution time stays the same regarding of input size. For example, input size is 100, and for example, it takes 10 10 loops are working on it. So if it's increased, for example, it goes 100 input, it goes sorry 100 elements. So in input output side will be same. So this exactly is the order of one constant time, like accessing the array element using its index. So it will be constant time. Even your list size is 1 billion or 1 trillion, and if you want to find fourth number or third number, so you just pass the index and the array name. So you would get it very quickly. Next is order of log n. This is logarithm time. The input size is reduced by half in each array, in each step. This will you use in binary search. Uh, for example, you have 100 numbers from 1 to 100, and you want to find uh, 50th number. So what this algorithm do? It will take the lowest number, then it take the highest number and divide with the two. So 100 divided by 2 could be 50. So it jump directly into the desired number. And if you want to find, let's suppose 25 in your list, so first it will come in the between of the number 50th, then it's see your target number is less than or greater than the middle number. So the target element is less than the middle element. So the starting element would be same 0, but the end element would be moved from 100 to 50th. Then 50 divided by 2 would be 25. So again you find your desired number. But if the result your target element is not available in the list, so it will just give you the it will give you the message it is not available in the list. Next is linear time. This is also it is also very good. The execution increase directly with the input size. If your input size is 10, so it will perform 10 times. If it is 100, so it will increase to 100. If it is 1 billion, so it will goes to 1 billion. Like traversing all elements in a list using one loop. Next is order of n log n time. This is linear arithmetic time. Combination of linear and logarithmic work common in efficient sorting algorithm. Like when you study merge sort or quick sort, so it will very useful. Next is order of n square, which is quadratic time. This is you can say that worst one when you apply two loops. So when it will use. So we don't prefer this because it is also called brute force. When you go step by step, you don't miss any step. Go apply two loops like this is outer loop, this is inner loop. Next we see simple real life analogy. Order of one, this is a constant time. Order of log n that you will use in binary search. Next is order of n. For example, you want to check books one by one in a library, and then order of n square. You will try to make pair of one student with every student, then second student with every other student, etc., etc. The smaller time complexity would be faster algorithm, and the larger the time complexity will be, lower the algorithm would be. Okay, now we can now move towards the question. Okay, let's move towards the question. Let's read. The main goal of the problem. Let me show you the problem once again. We need to reverse the list in place without using the built-in reverse method or slicing method that is available in Python language. So this is your input list and you simply have to reverse it. So the main goal is to reverse but without using the built-in method. Okay, let's move towards the question. Here is the list. Uh, for example, if you say numbers dot this is a reverse method, and if I try now numbers, so you see 3 7 and goes up to zone 5. Now it has been reversed 5 9 etc etc. We are not going to use it. Or there is one more method, slicing. What we do in slicing method, we give the start value. For example, the start value is 1. The ending value is, let's suppose, 8. And how many step you want to perform? Do you want to miss any step? No. If you don't want to miss any step and you want to go in a linear time 1 2 3, then you will apply here 1. It is it will tell you the starting position, it will give you the last position, and it will tell you how many jumps you want to perform. So you want to perform one jump, but we are not moving from left to right. We want to move right to left. We want to move right to left. So in this case, you don't need to write here 1. Don't need to write here 8. You can, if you just simply write -1 here. -1 means it will start from the end and goes up to so on the first value. You see, the result is still same. 5 was in the last, now 5 in the start, and 3 is in the end. But we are not going to use it. We need to use other method because these are very important. And when you try to go to give FANG interview, they will tell you which algorithm you will use. Of course, you cannot use this method. So in this, you will use two pointers problem. Two pointers problem. One pointer will stay in the start and second will be remain in the end. So what you will do, you will just swap the value. 3 will be swapped with 5 and 5 will come at the place of 3. Next, a left pointer will be increased and right pointer will be decrease one position backward. 7 will be reversed with 9, swap with 9, and 9 will be swapped with 7. Again, left pointer will increase, right pointer will be decreased, 2 and 1 will be swapped, then 8 and 4 will be swapped, and in now it comes in the middle. Now you don't need to swap anything because your list has already been sorted. Now 4 comes at the position of 8 and 8 goes at the position of 4. Now if you still swap the value, then it will again come to its original position that we don't want. We just want to reverse it. So you will first create left pointer that will point to the first value, and the right pointer will be stay at the last position. What is this last position? 0 1 2 3 4 5 6 7. Wait, 1 0 1 2 3 4 5 6 7 7. You can use this. You can just manually write 7. But imagine your list contain 1,000 number or 1,000 number or the number that you cannot count. That's a very long list. So what you will do in this case? You cannot write manually. So in this case, you will use length method, and here you will pass the list -1. Why did I say -1? What does it mean -1? Indexing in Python or other languages uh, starts from 0. Starts from 0. If I say 0 1 2 3 4 5 6 7, that means the last element is at 7th position. But if I say how many elements in it, 1 2 3 4 5 6 7 8, 8 elements. If you don't write 8 here, so it will try to go 0 up to so on 8th element, which does not exist in it. sorry, ninth element. It try to find the ninth element which does not exist in it, and in the end it will give you, it will return you the error. That's why we are using -1. So 8 minus 1 would be 7, so it will point to this value. I hope you understand this concept. Next is while left is less than right. Hopefully, this will be clear to you. While left is less than right, like 5 will be swapped with 3, 9 will be swapped with 7, 1 will be swapped with 2, and 8 will be swapped with 4. And then we don't need to swap any value because our list has been come in the decreased order, in the reversed order. So that's why we are not using it. Then we will swap. There are two methods for swapping here. First, I will tell you numbers left. We want to swap this value with this value. Numbers of RAGS6. That means number of right is this 5. That will be goes on this value. And number of right will goes to the left. This also works fine, but this can be looking long and difficult. So I would go with this method. I will tell you. This is new, but works very fine. Numbers of RGST. I will tell you what I have done here. Numbers of, okay, let me tell you what it does. Number of left is 3 and number of right is 5. 3 and 5. And number of right is 5 and number of left is 3. So 5 will be goes on the position of left. This will be replaced with this, and number of left, which is 3, will goes to the number of right, which is 5. So that's how it will work. And then, as I told you, we will move left to one position, right. Left will be increment 1, and your right will be decrement one position backward, because after one iteration you need to step back for right and step right to left. Hopefully this will be clear to you, and you can also write left is equal to left plus 1. This is a short way to write this, but you can even write this RIGST right is equal to RIGST right minus 1. And as I told you, we have done that all things in place. In place mean you have to make all the changes in your original array. You don't need to create anything else, any new array, because we want to save the space. And in the end, we can print this list. There is error. Numbers of left, right, RAG. There is a spelling mistake on this. There is some mistake. There is some mistake. I have no mistake. Let me see the mistake. List index out of range. Why is that? Oh, I have forgotten to write -1. Sorry. No, I see. It is working fine. When I was teaching, I have forgotten to write -1. I'm really sorry for that. So now how it is working? Uh, if I open whiteboard, oh sorry, whiteboard, I can show you how exactly is it working. Just give me a minute. And I can even tell you here. So you see, here is 3, here is 5. Both swap each other. You see, 5 is the at first position and 3 is at the last position. Next, you move left pointer to this position and right pointer to this position. Again, you swap the values. 9 comes as second position, 7 goes to the second last position. Again, left pointer move this position, right pointer to this position. Again, you swap 2 and 1. 2 is here, 1 is here. Again, left pointer move to this position, right pointer to this position. Again, you swap the values. 4 is here before 8 and 8 goes after 4. Now in this position, it will ask is left and right. Left, let me just see, 0, 1, 2, 3. Is 3 less than 4? Yes, condition is true. Then your left move to this position and your right, here is your right and here is your left. Now your left is 3 and your right is 4. Now in this condition, it will be false. Left is not less than right. And oh, sorry. Left is 4 and right is 3. Is 4 less than 3? Condition is false and of the it will come out of this body. While loop works as much as when the condition is true, and when the condition falls it will come out the body of loop, and then it will print this statement saying print the original list of numbers, and here is our original list. Hopefully this concept clears to you. I have written something else in my word file. So these concepts we have used here. List in Python we use word list, but in other languages like JavaScript or C++, Java, we use word array that stores uh, multiple values into it. Next is indexing. Indexing can be understood as like you go to hotel and they give you key and said, yeah, your room number is 25. So 25 is the indexing of your room. Next is length. What would be the length of your array? Variable. Variable can be container that stores something. That can be a pack of chips which store potatoes in it. Next is while loop. As I told you, while loop repeat until the condition is false. When the condition false, it will come out the body of loop. Next is, sorry, I'm really sorry. Yes, you know. Then we see swapping. Swapping mean swap one value with another value. Change one value with another value. Two pointers problem we have seen here, left and right pointer. Then we see in place mean modify the original list. Don't create a new one list. Time complexity is how much efficient for the algorithm is. In place, as I told you, without creating another list. What would be the space complexity in this problem? But space complexity is order of 1 because you just created two pointers left and right. There is not any other pointer, and pointers are not even increase its length during the loop because you are not consuming extra space for list. Why two pointers technique is important, and it will use lot of others method too, because to reverse the array palindrome problem, sorting algorithm, binary search variations, linked list, sliding window problem, and this is also very important coding interview. I think so done. I think so I've done. the video gets too much long. I'm really sorry for that. But my purpose is to teach you each and everything that can be asked in interviews whenever you are solving any kind of question, so you don't have any kind of doubt in your mind. You just ask from yourself. Whenever I stuck anywhere in any problem, so instead of directly jumping into ChatGPT, I try to decode it by myself. If I am then still failed, then I take a hint, not jumping into the solution directly. Okay, so just follow these tips along with me. I'm here. I will teach you each and everything what is important, and I am also going to start a new series where we will discuss five very important Python questions every day. I think so. I have created 100 questions and five questions each day, and I will try to make 7 videos in 7 days. Don't miss any day. Okay. Oh, I have forgotten to take one more example of let's suppose a string is equal to h p. Sorry. Hello. If you try to reverse this again, it will use the same method. Let me show you. Can we do it with the help of stacking? Let's see. I'm not sure about this. Uh, colon -1. Let's see. Does it work? Yeah, it is working fine. It's working fine. It's not creating any kind of problem. You can also use lot of test cases. You can make lot of questions by yourself. If you are unable to make, then you can take help from AI. So create 5 questions, difficult question, easy level question, and then try to debug it by yourself, so that your train will be habitual of these kind of problems. So whenever you encounter any difficult problem, so you wouldn't need to take help from anyone else by yourself. I think so. Reverse method will also work. If we are in string dot rev reverse. Let's see that it works. Yeah, it is working fine. So this is our problem. I hope you like the video. I know the video become very long, but thank you so much again.